Good evening, all. I welcome all the participants for this online lecture series on research scope in emerging areas of civil engineering on 8th day. So, today I'm going to give you a lecture about an overview of emerging contaminants and their advanced treatment techniques. Before starting this session, I'll introduce myself first. I'm Dr. Anjali, Assistant Professor in the Department of Civil Engineering at Aditya University. So, this lecture definitely new to the people, those who are in a UG level, and it will be very useful to the PG and the PhD students. And regularly, we used to think about the wastewater and what are the treatment process are there and all. We used to discuss here, but this may be new to the UG students, but they can know what currently happening in the world. So they will get an idea about what research is actively going in the society. So we'll start the session. So today I'm going to give the presentation. So we'll start with the introduction and what are the sources of emerging contaminants. Simply we will call it as ECs. So what are the sources will be there and how this emerging contaminants are classified and what are the effects due to this emerging contaminants and what are the analytical techniques are available and what are the different treatment techniques also present to treat these emerging contaminants and what is the pathway how these emerging contaminants is enter into the environment and this is the general introduction we can see here, and apart from this I'm going to explain particularly about the pharmaceutical component and what is the classification and what is the literature review here is what is the occurrence of this pharmaceutical components and as global as well as Indian scenario and what are the challenges that we are facing in the emerging contaminants and what is the future scope is available in this area means further what are the research that we can do. So this is the overall presentation. We'll start with the introduction first. So what do you mean by emerging contaminants? So emerging contaminants, it's not a new thing, it is already existing in the environment. So emerging contaminants, this is not a new contaminant which is already existing in the environment, which we are not monitoring regularly. And more active research is taking place in this area. And globally also, so many research are going in these things. And as I said, it is not monitoring or regulating properly. So these emerging contaminants are found in the range of nano to milligram per liter. So if you see the previous literature from 2010 or 9, see they found in the nanogram level of this pollutant. Later in the mid region, they can you see that it is in micro. Recent papers and all you can see they are found in the milligram per liter. So why we need to focus on these emerging contaminants? So it is causing the potential adverse effects onto the environment as well as to the human health. So what are the effects generally will be there? No, so there will be an endocrine disturbance is taking place in the organism and bioaccumulation is taking place in soil, plants and animals and microbial resistance. That means antibiotic resistant genes and bacteria are developing due to this pollutant. So and another thing, why it is not possible to remove by the conventional wastewater treatment plant means the wastewater treatment plant are designed to remove the pollutants like heavy metals or whatever the wastewater parameters are there, that only we will remove. The treatment is not designed particularly to remove the emerging contaminants. That's what it is not completely removed or it may be the partially removed. So the inefficiency is there in the normal or conventional wastewater treatment plant. So where this is implemented, you can see there will be an n number of emerging pollutants are there, but you can see here where it is regulated, few components they are included in the European regulation for monitoring programs and they listed the priority substance. So what is the priority substance? I said n number of pollutants are there, right? So in that, which we need to focus or which we need to give more importance to that substance. So you can see in the European, they regulated to the European level under the Water Framework Directive and they are planning to implement in the treatment plant also. So by Okay, 2045. So they are planning to remove the 80% of broad spectrum of micropollutants. What is that broad spectrum of micropollutants means? I said right, emerging contaminants is a very broad area. It will contain lot of classifications are there. So in that at least means they can remove the antibiotics and micropollutant. Few parameters they are planning to remove through the normal wastewater treatment plant. And you can see Switzerland also sanctioned a new regulation to this pollutant. So, so this is the small introduction about the emerging contaminants. So, among this, you can see or you can go to the website Norman Substance Database. So, he classified that website showing that emerging contaminants can be classified into 21 categories. So, in that, I listed few things here. You can see the pharmaceutical and personal care products, that simply we will call it as PCPP. Agriculture, so pesticides will come from that agriculture runoff. Then you can see the surfactants, disinfection byproducts, and flame retardants and industry chemicals, and among so many are there. So whichever is important that I have given here. So currently you can see that POPs, what is a POPs? Persistent organic pollutants also placing a major role in the research area. So among this, currently they found 700 emerging pollutant along with their metabolites and transformed byproducts is listed in that European aquatic environment. You can see, and they are frequently updating whatever the pollutants are emerging there. So you can see that Norman. You can go to the Norman website database. You will get all the pollutant and list of priority substance also it is there. Okay, so far, so I given the small introduction about the emerging contaminants, why we need to monitor, and what is the level of emerging contaminants are present in the environment, and which substances we need to follow, and what is the regulations are there. So with that, we'll go with the sources. So what are the sources for the emerging contaminants is there? So you can see that household discharge, veterinary and industry as well as hospital. Among with that, agriculture runoff will be there, aquaculture, and everywhere we are using the pollutant. Like a simple example, I can say that pharmaceutical or hospital. So pollutants are tablets that are discharging there. So this where it will end? So it will end to the wastewater treatment plant, or maybe to the environment, or maybe any water bodies. So next is occurrence or detection. So where we can detect? I said the sources. So sources you can see here, different places will be there. So where it is detected is, it is detected almost everywhere, all the water bodies I can say. So river, lakes, surface water, groundwater, and sediment, soil, biota, and drinking water also, and wastewater, and it is accumulated in food source also. So these are the places they at least they found the trace level, or they may detected in the range of nano to microgram per liter also. Okay. So next is, so far what I said is introduction about the emerging contaminants and what are the sources for that and what is the occurrence. Next, how it is entering to the environment we'll see. So there are different pathways are there. Sources already we discussed, right? So these are the sources I said. All this will comes to the, here I given antibiotic and analgesic. You consider the emerging contaminants also. So there it can enter into the two ways will be there. Like it can directly goes to the water bodies, or some of them will goes to the treatment plant. Here the treatment plant also, what I said is inefficiency will be there, means it not completely removed the my emerging pollutant. So what is happening if it is exposed to the environment at a particular time, antibiotic resistant is developing, so genes and bacteria is developed there. Example, I can tell you the paracetamol tablet is there, right? So if you are taking the tablet at 500 mg, if you are taking it frequently, what is happening? Our body will resist to that. If you take again also, that fever will not reduce. It means sure that our body is resist to the tablet. So again we'll go for the high dosage like 650 mg like that. So same here also, if it is exposed to the, means the bacteria is exposed to the particular uh, pharmaceutical compounds, the antibiotic resistant genes and bacteria will develop. So what is happening with that? So it will reduce, in case of human health aspects, it will reduce the efficiency against the bacteria, and it will reduce the mortality rate. In case of aquatics, you can see it will reduce the reproduction system in the fishes, and it will create the hormonal imbalance also. So one study says that you can see 7 lakh death maybe happen in the year 7 lakh death is yearly by the drug resistant pathogen, and it is estimated that 10 million people may die by this 2050. So this is the one paper giving, you can think about 7 lakh due to only the antibiotic resistant bacteria. So next one, as I said, it is a broad area, emerging contaminants. So what are the classifications are there in that? So first one, we'll start with the pharmaceutical and personal care product. As I said, simply we will call it at PP, CPS. Another one, flame retardants. So first, we'll see with the pharmaceutical and personal care. Pharmaceutical, obviously, tablets what we are consuming. Example, I can say paracetamol, amoxicillin, azithromycin. So all this comes under the category of pharmaceutical. And personal care products means how day-to-day life what we are using, like cosmetics, shampoo, soap, paste. All this will comes under the category of personal care products. Next one is flame retardants. Generally, it is used in the fire extinguishers and all. And industrial discharge, obviously, chemicals will be there. And another one is PFAS. This will comes under the category of POS, that is persistent organic pollutant, pre and polyfluoroalkyl substance. Simply we will call it as PFAS. Another one, surfactants. Obviously we know we are using the soaps and all for washing. So there this chemicals will come. And microplastics, this based on the plastic size we will say it is micro or nano. Another one, endocrine disturbing chemicals. Here EDC will comes in it, generally it will affect the aquatic organism. And plasticizer, simple PVC pipe and all will comes under this category. Next pesticide is agricultural runoff, where we are using the pesticides for agriculture feed. So these are the different classification. Apart from the few are there, so which I given is the more research is taking place. Among that also you can see EDC, PFAS, PP, CPS are more active research is taking place in this area. Those want to do a research as a scholar or MTech people, they can focus on this area also. Okay, so let us continue with that. So as I said, from PP, CPS, first example is antibiotic, painkillers, hormones. These and all comes under the category of pharmaceutical. And next one is personal care products. I said right, cosmetics and all. Next one, endocrine disturbing, BPA. So we can see that in water bottle and all, they will mention like a BPA free bottle. If you noted, that BPA will be there. Another one, pathways and dioxin. Next one is PFAS. Here also two things will be there. This two area also current research is going. PFOS, that means perfluorooctane sulfonic acid, and PFOA is perfluorooctanic acid, and other fluorinated chemicals also there. And you can focus on these two areas also. So here I'm giving the few examples only. There will be a lot of classes. In that also there are many subclasses are there. So here few examples I can give. If you want, you can go to that website Norman database. You can get all the data. And here pesticides and herbicides, obviously atrazine we will use that one, and nanoparticles and microplastic. I said right. So based on the particle size, so we'll call it as microplastics. Another one, industrial chemicals, PCBs, polychlorinated biphenyl, solvent, and plasticizer. Plastic, obviously the PVC pipes and all comes under this category. So far, so what we discussed, what are the classification? In the classification, what are the subgroups are there? What are the pollutants are there that we discussed? So what will happen with that emerging contaminants? You can see what are the effects. So I given the three effects. What is the effects on the environment? What is the ecotoxicology effects and human health? So you can see the first one, environmental effects, where we can persist. It is persistent, means it is we could not remove it easily. So it has detected in rivers, lakes, groundwater, and aquatic ecosystem is all. And pesticides and plasticides, you can see that it affecting the plant growth and fertility. Another one, flame retarders, I said right. Next one, so what is happening, ecotoxicology effect, endocrine disturbing in a fish, and reducing the fertility rate in fishes also. And bioaccumulation is taking place in food chain, and alteration in the breeding season. Apart from this, It is creating the hormonal imbalance also, and these microplastics are absorbed in fishes also. That is the reason microplastics also one of the emerging area in this emerging contaminants. And what are the effects as the human we will get it in infertility, early puberty, and thyroid disorders, and we will get it, and liver damage in human system. So all this will comes under this human health effects. And what I said, right? Development of antibiotic resistant. Our body will resist to that particular tablet. So again, that is the reason we are going for high dosage. So these are the effects generally occur due to that emerging contaminants. So, what are the sources and classifications, and what are the effects we discussed now? So, how to detect that? That is a major task in this area, I can say. Why? Because no, it is present in the nano, micro, and milligram. So not all the pollutants will present in the milligram. It will present in the nano and micro also. So in that case, detection is very difficult. So we can trace it. For that, sophisticated instrument is required to find out this. So here I given the overview of what are the different analytical instruments are available to detect this one. So you can see for this emerging contaminant generally will go for GCMS, LCMS, HPLC. So this three majorly will focus for emerging contaminants, and in ICP is also there, that is to detect the metals actually. So here GCMS equipped with mass spectrometry. So what is that mass spectrometry? It will use it to find the degraded products. Generally liquid chromatography and GCMS will go used for find the whatever the transformed products are there, or metabolites, so that we can detect with the help of mass spectrometry. In that also again you can see that three classifications are there. That is very high level. So for example, if you want to find a sensitive or whatever I targeted, that only we can focus with that mass spectrometry, triple, quadruple, and time of flight, and linear intra. These and all selective ions only we can get. And one facility will be there in GCMS is you will get the molecular structure also for the transformed byproducts. And next, HPLC is there. So generally, at least basic level HPLC is required for that high performance liquid chromatography. Their role is it will separate the pollutant, or it will separation will takes place whatever we are targeting in that, and we can identify then quantify how much it is there. And this HPLC, for all this we need separate column is there. So like for example, C18 column will be there, and that detect only few pollutant. It is not possible to detect all the pollutant. So here column also we need to change for this HPLC. And another thing, it is required mobile phase also. So if you want to do this with HPLC, obviously mobile phase is required, elution period is required, standards required. Along with that, you need column. So column is very important. Which column that we want to use? So generally for my research that I have used C18 column for that particular pollutant. So next, apart from that, other techniques are there. So generally, another techniques here, they will use NMR for identification of this pollutant, and the thin layer chromatography. For all this and all, separation will take place. The overall process behind this is separation is taking place, separation of the pollutant, and we can quantify how much it is there. For example, if pollutant is present in milligram, after particular treatment, how much it is removed, that we can estimate here. So this is the analytical techniques. So many things there to explain. And if you go with the LCMS, so operating conditions also there. At what temperature we need to maintain, which column that we need to use, what are the solvents is required. Sometimes some pollutant we could not give as it is. So solvent is required to extract that pollutant. So okay. So like that, all this processes involved here. Next, so analytical techniques. Then we'll discuss about the advanced treatment techniques. Generally, physical, chemical, and biological process will be there, right? So same way here also, they are using the adsorption to remove this pollutant, activated carbon But all these methods, what we are facing here is some limitations will be there in all the treatment methods. Apart from that, we need to focus which is giving the best result or less toxic pollutant, that is where transformed products and all. So what is the efficiency, all these things we need to consider. So I'll give you the overview of what are the advanced treatment techniques are there. So first one, you can see that the adsorption will comes under the physical method. Here the physical method is required. Again, we have to regenerate whatever the materials that we used. Next one is ozonation. Here, generally ozonation will give you the good result. The problem here is control of ozone dose is difficult and energy is required, and it is also generate the more byproducts. And apart from this, this ozonation will works on two ways. Direct way will be there and indirect will be there. So if it is an indirect way, hydroxyl radicals, actually for removing this advanced chemical treatment, if you take there, no, hydroxyl radicals plays a major role for degradation of this kind of pollutant. And you can see the advanced oxidation process here. Most majority of research will choose this AOP process. Why? Because the hydroxyl radicals will play a major role to remove this or degrade this kind of pollutant. And here there will be different methods are there, like a single method you can use it, combination and hybrid also there. If using the hybrid method, maximum removal efficiency we will get it, and we can check the transformed products also whether it is toxic or non-toxic and all. This AOP will see in detail what are the different combinations will be there in that. So next one, UV radiation. So only UV radiation also we can use, but the problem is removal efficiency will be less. So does not effectively remove all the contaminants. But you can use this UV with other combinations like UVH2O2 or UVO3, like that combination we can do. Next one is electrochemical oxidation is there. Here we are using the electrodes to remove this one. And membrane, obviously we everyone knows that membrane filtration process, like RO will be there, ultrafiltration, nanofiltration. And but this membrane filtration will not like high energy is required and regular maintenance also there. Another problem is it is little difficult to remove all the pollutant. So next one is biological treatment. Nowadays, they are using the algae. So advanced biological means with the help of microorganisms, microorganism, emerging contaminants are all removing. But you can see here required careful control of the environmental condition. If you want to develop or if you want to grow the algae in the setup, means we have to maintain that condition properly, otherwise the algae will die. So that is the only drawback will be there here. And accumulation also will takes place in the algae. So these are the few limitations will be there in this method. Another one, photocatalyst. Photo means obviously light. You can use the UV light or solar radiation also. We need some catalyst. Generally people will use TiO2, titanium oxide, to remove this. And I said right, it requires UV light or maybe the solar to remove this kind of this kind of treatment technique is required. Next one is electrocoagulation. Here it requires power and sludge will generate. Okay, so these are the advanced treatment techniques. In that we'll see AOP. I said right, so AOP will contain number of groups, I can say. So advanced oxidation process, simply we will call it as AOP. Here you can see UV photolysis. So with the help of UV light you can photolyze, and you can see the combinations here: UVH2O2, UVTiO2, UV chlorine, and different combinations. With only UV will not remove all the contaminants effectively. That is the reason we are combining with UVH2O2 and all. Next you can see the ozonation. So ozonation, so all this process will works under the generation of hydroxyl radical. So here UV O3, O3 or H2O2, hydrogen peroxide, and UV. So you can see the combined process like UV, H2O2 and O3. So like again you can see that there is a different combinations will be there for this AOPs. And ultrasonication also, because of that vibrant the pollutants will uh, destruction will takes place, or it will separate. Another one, oxidation process and phenton process. Photophenton, here also modified photophenton will be there, normal photophenton will be there, electrophenton and modified electrophenton. So many methods, so many combinations are available in this advanced oxidation process. So we'll see in this AOP process in detail in further slide. Okay, up from this, so what we discussed here is what is the introduction and what are the sources for the emerging contaminants and what are the classification and what is the effects that we will get it and what are the analytical methods are there to detect these kind of low level concentrated pollutant and what are the advanced treatment methods are available. So now I'm going to explain particularly about PPCP. So in that also, so PPC already I said, right? Pharmaceutical, personal pollutant, pharmaceutical and personal care products. So that, so we'll see the pharmaceutical components in that also. So you can see that slide. Pharmaceutical compound, there will be different classes or groups will be there. Antibiotic, analgesic, antidepressant, stimulant, painkiller, hormone, so many are there. All this will comes under the category of PCs. Another thing, personal care products. So I said, right, day to day life what we are using, soap, lotion, paste, cosmetics, all this will comes under the preservatives also comes under the personal care products. So today we'll discuss about this pharmaceutical compounds. Simply, I'll call it as PC. So, why we need to focus on this pharmaceutical compounds? Okay. So many are there, right? In emerging contaminants, I said broad area. So many groups I have shown there. Even though particularly I'm choosing this pharmaceutical compounds. Why? Because it is one of the important group in the emerging contaminants, and more research worldwide, more research is taking place, and more persistent pollutants are present in the environment. And what is the sources for this pollutant here is medicine, industries, livestock farming, aquaculture, and people day to life. Whatever we are consuming, like tablets and all, that will comes from the daily life. And this is another reason. What is the reason to increase these pollutant is extensive usage. So, for example, I can say COVID-19. We used paracetamol, right? Too much. So because of that also, the concentration of the pollutant is increased. Okay. So extensive usage. Another one, the problem, as I said, is poor removal by the conventional wastewater treatment plant. Why? Because that is not particularly designed for the emerging contaminants. And another reason is there for selecting this PCs is India is one of the top five emerging pollutant manufacturing country. And another thing is one of the largest drug consumption. Next one, it is 11th ranked in global consumption of over-the-counter drugs. So what do you mean by over-the-counter drug means? Without prescription. So without prescription, we'll go to the medical shop, we'll take the tablet, right? So because of that also, the concentration is increased. So according to that, 11th rank they given for the over the counter drugs. So this all these things brings an attention to focus on this pharmaceutical pollutant. So we'll see here what is the occurrence. So PC means pharmaceutical compounds. We'll see globally what is the pollutants is occurring, and Indian scenario also we can see. So occurrence of PCs global level. So already I showed there in that classification PPCBs. So here you can see the antibiotic, the author. So how many pollutant they have detected. Another one. So these are all the groups comes under the pharmaceutical compounds. And another side you can see analgesic. So these two placing a major role. So here the amoxicillin, as we all know, amoxicillin tablets, ciprofloxacin, azithromycin, paracetamol, everything, right? So this antibiotic and analgesic is more pollutant is present. So here two things that three pollutant that I'm going to explain here. From antibiotic, two will be there. Amoxicillin I already highlighted, amoxicillin and ciprofloxacin, and analgesic acetaminophen. That is also called as a paracetamol. So another thing, stimulant will be the beta blockers and antidepressant lipid, so many are there. Okay, so globally these are the pollutants are actually this is a group and these are the pollutants is present. Next, so occurrence we have seen, right? Means occurrence means at least they have detected. So these are the pollutants are presented in the environment. So we'll see what is the concentration. So we have to see the concentration also, right? So globally we can see. So this first, second generation I'll explain in the upcoming slide. You can see the amoxicillin. It comes under the second generation of the beta lactam ring. So these are the pollutant were detected in different places. You can see in the time like 16 and 2007 they have detected in the range of nanogram per liter. But next one you can see the ciprofloxacin, that is the second generation. It comes under the fluoroquinolone. So all these others you can see 630 in Italy and Canada in 620. Even if it is present in nano also, a big issue or threat to the environment as well as to the human health. Next one. So this I said acetaminophen is also called as an paracetamol. Paracetamol you can see in different where. What is the concentration here? 92,000 and 49,000 nearly USA. So this concentration is high. Okay. This is the first generation of analgesic. So this up to this is the concentration about the global level. We can see in Indian scenario. So what is the occurrence and what is the concentration present in India? So these are the different places they have detected the pollutant like pharmaceutical compounds in India. So STPs means treatment plant and rivers, forest and lakes, different colors identified. So you can see the occurrence. Here I'm focusing only on the two major group comes under the pharmaceutical compounds. One is antibiotic, another one is the analgesic. So you can see that STPs, how many pollutant we have detected in our India. Okay, so in that acetophenomena, that is paracetamol is also there, amoxicillin also there, ciprofloxacin is also there. Okay, so next one. So this is the occurrence. I have chosen only two group, antibiotic and analgesic. So I listed what are the pollutant that we have detected in different places in India and what is the concentration. So you can see here. So once the way it is entered to the treatment plant, what is the concentration? It is in nanogram. You can see amoxicillin. After the treatment process, the effluent what we are discharging into the environment, it is present in 62.5 nanogram per liter. Even it is shows that the removal efficiency is less in the conventional process. Influent and effluent, especially in the Delhi STP, sewage treatment plant. Next one, you can see in the Hyderabad STP. Actually, this is located near to the industry, pharma industry. So that is the reason the concentration is very high, like it is present in the milligram per liter. In the 2009, the database that I have shown here is 2009 paper. So ciprofloxacin is 14 milligram and effluent. Here I'm showing the effluent means after all the process done that the wastewater is going to discharge. The concentration detector is 14 milligram. Next one, Hyderabad Lake, you can see again ciprofloxacin is 6.5 milligram per liter. Next, UDP STP. So both influent and effluent is there. This is for paracetamol. It is detected in nanogram per liter. Another one, Mangalore STP. So influent is 4500 and effluent is 340 nanogram per liter. Okay. So this is detected in the river. The concentration, that is paracetamol concentration is 1.565 microgram per liter. So here itself you can observe very clearly, like it is present in nano, micro and milligram also. Okay. So before starting this, we have seen the global level what are the pollutants are there and Indian scenario what are the pollutant we detected and what is the concentration is present in that particular STP, rivers, forest and all we discussed. Now we'll see the what are the chemical treatment methods. I'm focusing on here chemical treatment methods. What are the different chemical treatment methods are adopted to remove this pollutant. So particularly I'm focusing on three pollutant as I said. I have taken two antibiotics and one analgesic, that is paracetamol. So first you can see the amoxicillin. So in the period of 2010 and all you can see more research is happened in the single removal of single pollutant. So here you can see that amoxicillin is removed 50%. It may be a single treatment method or maybe the combination of method or hybrid method. So you can see 65 percentage, 54, and photofenton is giving 100% removal is there. Okay. Another one you can see the paracetamol. Simply we will call it as ACET. So the removal here they focused on single removal and with the combination of different treatment techniques or maybe the single method. So almost the removal is achieved 70 to 100 percentage there. Next one you can see the SIP, that is ciprofloxacin, and these two, please remember amoxicillin and SIP will comes under the antibiotic and paracetamol will comes under the analgesic. Okay, so here you can see that what is the removal? Same thing. Here also 100% removal is there. So this and all from 2018, 12, 10, 13 and all. Research is focused on the removal of single pollutant with the single treatment method, binary or maybe the combination or hybrid method to remove this. So later you can see from 15 onwards, slowly the research is focused to remove on the binary pollutant. So 2015, they used the two pollutant at the same time with the combination of photocatalytic ozonation and removal is 68 percentage as achieved. Next you can see in 17, again AMX and SIP. So here completely I am showing the binary pollutant with the combination of treatment methods. So 2018, you can see the metrophin and amoxicillin photocatalytic removal. In 2019, ACT and AMX, they use the ozone oxidation process and solar phenton for solar photophenol. Two methods they apply to check this binary pollutant removal. They achieved 84, 82 and in synthetic 90 percentage in synthetic removal. Next, 2020, ozonation combined with hydrogen peroxide, that is 100% removal is achieved. Okay, so far I have shown the single and binary. So you can see the trend, how the trend is changed to period of time from 2010 to till 2015 or 2020, 23 and all. Slowly, so up to 2020, they focused on single and binary pollutant. So now the trend is changed again. So instead of focusing on single or binary pollutant, now they focused on multiple pollutant. That is simultaneously removal of multiple pollutant with the combination of different treatment methods. So here you can see this one. So up to again from 2017, the removal of mixture of pollutant they focused. Here you can see the different pollutant and different combination, that is hybrid method they used, and the removal efficiency is achieved 64, 80 and 50 percentage. Next 2018 you can see they tried in hospital effluent. These are the pollutant they removed with the help of photophenton. Here photo means already I said light, so they used the UV light to detect the 80 to 90 percentage. Next 2019, they used different methods. Only they tried with the UV, next to ozonation, phenton, and the combination of phenton and UV method. So likewise, you can see the trend from 2017 to 2023 and present. The research is completely focused on removal of mixture of multiple pollutant with the combination of different treatment methods or maybe the hybrid method they are used to remove the pollutant, and they are almost achieving the 100% removal also. Okay, so far I explained the right antibiotic and analysis. Why we need to focus? So far we discussed PCs. What is the classification? What is the group? PCs contain different groups. Antibiotic analgesic. In that also we have discussed the occurrence and what is the concentration and what is the different chemical treatment methods are available, and why we need to focus particularly on these two groups, antibiotic and analgesic. So you can see here, so generally these antibiotics will use widely used and high concentration has been detected in the hospital wastewater and maybe the wastewater also, and conventional process I said biological process is not favorable to that particular. So because of that, what is happening, development of antibiotic resistant genes and bacteria is developing. Another one, the report says that you can see how much of antibiotics that we are consuming is 0.1 to zero point 0.2 million tons per annum. So think about how much of antibiotics that we are utilizing as the worldwide. Next, obviously, everyone knows acetaminophen, paracetamol. So that is regularly used for fever, painkiller, headache, etc. So approximately how much that we are discharge is 50 to 68 percentage of paracetamol is excreted from the human, and we are discharging into the wastewater treatment plant. And so this particular paracetamol, how much global consumption is 100 tons per year. 100 tons per year that global consumption is there, and they have been absorbed in the range of zero point 0.1 to 10 milligram per liter in wastewater. So I said right, the slowly the trend has changed from 2010. They deducted in nano and then micro. Then now you can see it is in milligram per liter. Okay, so in this antibiotics also different classes will be there. Okay, so what is the important core structure and generation of antibiotic? So I said right, first generation, second generation, and all. So antibiotic you can see there. First one classes will be there. Amino penicillin. So everyone knows that penicillin injection will be there in childhood time. So their name is amoxicillin. Penicillin will be there. Then fluoroquinolone. So here first, we'll see this penicillin, fluoroquinolone, macrolides, and tetracycline. So these are the different classes comes under the antibiotic. So you can see the subdivisions first. First, we started with PPCPs, that is pharmaceutical and personal care products. Then we have taken only the PCs, pharmaceutical compound. In that also so many groups are there: antibiotic, analgesic, antidepressant, stimulant, and all. So here I have taken two, that is antibiotic and analgesic. In that antibiotics also subdivisions will be there. So penicillin will be there, fluoroquinolone, macrolides, and tetracycline. So in this, whatever the pollutant I said, like amoxicillin, ciprofloxacin, and paracetamol, we can see the generation. So first, we can see the first generation will be amoxicillin. Next, fluoroquinolone. You can see the second generation, ciprofloxacin, and ciprofloxacin will be there, as well as what is it, paracetamol comes under the another group, analgesic. So you can see the generation first, second, and third. Now fourth generation also came into the picture. Like, so because of their generation, the pollutants also increasing, their persistent level is also increasing, the concentration is also increasing. So we have to reduce that. Okay, so these are the classes comes under the antibiotic. Okay, so why we need to focus on this selection of that is the reason I said right. I have taken two groups. One is beta lactam, amoxicillin, fluoroquinolone, ciprofloxacin. One is analgesic, paracetamol. So reason is extensively using this three pollutant and high concentration has been detected in the wastewater, and it is environmental stability that is persistent. It is very difficult to remove or degrade this kind of pollutant, and you can see in India the concentration of ciprofloxacin amoxicillin is in Indian STP, sorry, Indian wastewater treatment plant, 40 times higher than other countries. So you can imagine. So how much antibiotics that we are utilizing in our country? So 40 times higher than other countries in Europe, Asia, and North America. And another one, this three is commonly detected in Indian STPs. That is the reason I have showed that Indian picture, like how much concentration is particularly detected in different places like river, STPs, forest, lakes, and all. So predominantly present in domestic sewage. So this is the only one part that I'm showing here. So like that, so many groups will be there. Like you can imagine, you can think that damaging contaminants group. So like that, each group having many subcategories will be there. In that also, so many pollutants also there. So I focused only this. And what is the structure properties of this pollutant? You can see, and why we this required is we have to choose based on that only whether we can it is soluble in water or not, or it is required any solvent. So based on this pK value we can detect the strength of that particular pollutant. I said all the pollutants will not dissolve in water. Obviously some pollutant we have to dissolve with the solvent, and if you are going for any analytical purpose like GCMS and all, obviously we have to dissolve with the solvents to extract that pollutant. So then only we can do the analysis. Another one, LCMS is there, that you can give the liquid form like your sample should be in the liquid form, that we will see now. Okay. Okay, so far I said that why we haven't chosen this species or antibiotic, analgesic and all. Now how to remove that? Here I used that AOP process. You can remember that flow chart AOP has showed, right? Different classes or combinations will be there. So among this I have chosen the ozonation method. So obviously everyone knows what is the sources and where the antibiotics is coming and how to treat it. Now you know pollutant is present in the environment, the concentration also approximately we know based on the previous literatures and all. So now we have to treat it. So here I have chosen the ozonation method to remove this pollutant. Actually, so this image shows that ozone generator. So first a small one is there, right? That is for the oxygen supply. Next, the O2 will be converted into O3 with the help of ozone generator. Then the O3 will be goes to the reactor. So in the reactor, actually this is like a semi-batch method, I can say. Before that, I have prepared the liquid ozone. So then I applied in the removal then removal process has taken place. So here I have to prepare the liquid ozone. Once the liquid ozone is prepared, then I have done with the combination, that is I have mixed the three pollutant to check the removal efficiency and what is happening to the transformed metabolites or transformed products, and this transformed product is toxic or non-toxic, those things and all I have done this work. So here O2 will be there, O2 will supply, O2 will convert it into O3, the O3 will goes to the reactor. All this, the sample you can show here is considered that is the three pollutant as mixed in the reactor. So then the liquid ozone will be added to that to remove it. So for this removal, what I did it, and another one is there, right, to check the excess ozone, how much of excess ozone is releasing from that. So generally KI solution will be used to detect that. So here we have to optimize it, right? So for this optimization, the parameters which I chosen here is pH, ozone concentration and time. So with the varying of this ozone dosage and all, how much removal is happening for, because it is a two different groups. Consider, please think that antibiotics is there, analgesic is there. So we don't know, right? So we have to optimize where the removal efficiency is happening, maximum we are achieving with particular time. So another kinetic study is also done for this work. And then once the optimized, all the parameters is optimized, then I have checked the TOC, total organic carbon, like how much compounds are converted into a organic like CO2 and H2O2 and all. So once this has been done, the parameters is optimized with respect to the time, that sample is given for the LCMS. So whatever this and all I analyzed with an HPLC, the column which I used here is the 18 column, and whatever the sample that we are taking. For example, once the experiment is done, we have to collect the sample and immediately we need to quench the sample. Why? Because no, I said right, this is done with the process happening here in the ozonation is the presence of hydroxyl radical. So that reaction will continue. So if you want to stop that, we need to add the sodium thiosulfate to stop the further reaction. So once the sample has been collected, it should be quenched with the solution, then it should be stored. Then the optimized condition, that experiment again we need to do, the sample has been collected, preserved and sent for the analysis or LCMS. And another thing is there, whatever that we are injecting to the instrument like LCMS or HPLC, we have to filter the sample first, because all these are sophisticated and very small pore will be there. So all the particles, if a single will be present also, it will block it. So before injecting the sample into the methods, we have to filter the sample and we need to inject it. Next, generally we'll go for 0.22 micron size and 25 dia. So once the sample is filtered, that will be passed through that instrument. Then it will be given for, so there with the help of HPLC you can find the how much removal is happened and all. Only quantification we can do. So we could not tell whether the what I can say, products is degraded or converted into some other, or it is transformed into TPs and all. We could not find it with the help of HPLC. So we can go with the LCMS. So LCMS you can see. So for here only the optimized condition I have given. So here we will get the transformed products. So how many transformed products that we are forming here? So that we will see. So based on the peaks that we will get it. So we'll go for a, okay, I will explain this after a break. We'll go for a break for 5 minutes. Okay, welcome back to the session. So already I said, so what this optimized condition, if you want to find the transformed product that you need to go for LCMS. So from that LCMS, so what are the things that we will get it? So generally transformed products we can detect, and so with this pollutant, for example, I mixed with three pollutants, right? So what is the mechanism is involving? So here you can see, so this is the general mechanism, how this pollutants is degraded or transformed into some other, and what are the possible pathways are there. So that I'm showing here. So how the trend is like that is a pollutant, actual pollutant like amoxicillin 365. So from there, so by applying this ozonation method, how the pollutant is degraded and what is the mechanism, this overall mechanism, how the pollutant is degraded from stage by stage. So finally how it is converting to the non-toxic, like finally converted into water or carbon dioxide. And we need to check for this transformed products with this test, echoes or test, to check whether it is an toxic or non-toxic. Okay, so same. So this is for AMX, and you can see for three pollutants. So all the three pollutants, and another thing. Okay, generally this you can see here. Once the treatment is applied, like ozonation is passed, the pollutant where it is hitting first. So with the help of hydroxyl radicals, so this will the present, like whatever the marked, this site will be first affected, and this these two things, it will hit the hydroxyl radical first, and the transformed or byproducts is taking place, the pollutant is degraded. Same here for ACET, that is paracetamol. So here generally oxidation and hydroxylations were involved. So another one, CYP, that is ciprofloxacin. So reaction site. So whatever the marked here, that you can see, once the ozonation, it will hit the hydroxyl radical, so the product will change. So generally what is happening here, you can see. So first it will affect the loss of this piperazine ring will get affected, and then so this is the ring. So this will get loss, and second one, oxidation is taking place, like guanol structure. This is a guanol structure, and defluorination and hydroxylation is taking place. So this is the general mechanism which is involved in the process. So overall what is in the ozonation is, so three pollutants I mixed, I applied the ozonation method, I optimized the parameters. Once the parameters has been optimized, that sample has been given for the LCMS analysis to check the transformed products, and with the transformed products, what's the possible pathway, how these pollutants are degrading into different way, or different mechanism is involved here, and where the site, that is a reaction site where this hydroxyl radicals will hit. So based on this, so you can see the research. This has been published in the paper, Journal of Linear Production. Same. So this and all comes under the AOP process, like advanced oxidation process. Next method, you can see the UV phenton. So here I used the hybrid method, like UV as well as the phenton. So UV already I said, you can use the light, you can see that image. That is experimental setup. So both the three pollutants is mixed into pollutant. There will be an UV light will be there, and cover will be there. The solution will be present there. Then before starting this, we need to warm up the light for 25 or 20 or 30 minutes. Once the pollutant is added, we need to add the Fe2 plus and hydrogen peroxide we need to add. So once the reaction, like same here also, we need to optimize the parameters. So here I optimized the Fe, H2O2, pH, and then concentration. So here pollutant concentration also I varied. So based on that optimized the condition. So that has been analyzed in the HPLC column or HPLC method. Then So whatever the results, whatever the things that I have found here is what is the removal efficiency, what is the kinetics, and how much mineralized the pollutants is mineralized into, how much mineralization is happened, how much converted into carbon, and then we'll go for the degraded products. So here you can see the study HPLC, kinetic, TOC analyzer. Finally, I'll go with the LCMS. So already I said liquid chromatography, mass spectrometer. So this is the another method. Here you can see here 10 intermediates are formed. So this 10 intermediates again we need to check whether toxic or non-toxic. So based on that we can uh, check whether the converted is toxic or non-toxic. We can discharge or not. Okay. So here in this pollutant you can see the 9 intermediates. Another one 11 intermediate. This is same. Almost whatever the mechanism which I'm showing here, like ozonation, UV phenton or solar phenton, we'll see in the solar phenton upcoming slide. The mechanism is same. Like only the transformed products is varying. Okay, so you can see the less transformed products here. Okay. So this also published in the Journal of Water Processing Engineering journal. Another one solar. So here I used the solar radiation, direct sunlight I have been used for this, and you can see the setup here. So this is the obviously we need to keep in the mixing condition. So I use the magnetic stirrer, and RPM generally 500 to 600 range, that you can keep it here. Solar radiation will be there. Your pollutant is added here, and then same H2O2 and Fe2 added again. So whatever the samples we are collecting, we have to quench it first. So then before injecting to the HPLC or LCMS, we have to filter the sample, then we need to inject. All this analytical process, like whatever I'm explaining, like HPLC, LCMS and all, mobile phase is required. And this mobile phase is also not common for all the pollutants. So it will change based on the pollutant, as well as we need to change the column also. Okay, so that we need to take care while doing the research. Sample has been collected. Again, we have to analyze all the products, like how much efficiency, like how much degradation is happened, and what is the kinetic, where the reaction is exactly taking place, and what is the mineralization and products. So here you can see that 4 intermediates. Another one 6. So next you can see 7. So what I want to mean here is, and this also published in the environmental monitoring and assessment. So far what I explained here is, if you are going for AOP, like advanced oxidation process, the mechanism is involving almost same. So whatever the hydroxylation taking place, oxidation is taking place in case of SIP defluorination and all, the mechanism is same. The transformed product is important. How many transformed products are forming in each AOP method? So based on that, the transformed products also we need to check whether it is toxic or non-toxic. So based on that, we can select which is the best method we can choose for the removal of multiple pollutants. This all done with the simultaneous process. Okay, so next one. Okay, so far I explained the what is the PC. In PC, 2 groups I have taken. In that antibiotic, what are the classes are there? And in that antibiotic analgesic, 2 pollutant from antibiotic, 1 pollutant from analgesic, and I applied the advanced oxidation process to check the removal efficiency, how much mineralization, what is the transformed products, and it is toxic or non-toxic. Okay, so then apart from this, I have shown only few here. You can see here so many challenges are there in the emerging contaminants. So first one, detection and monitoring. That is also a challenge only. Why? Because it is present in the nano or micro or milligram. So very low concentration is very difficult to detect it first. So trace level only we can see. Next one, analytical limitation. So if you want to detect at the low level, so sophisticated instrument is required to this. And there is no any standard protocol for this pollutants. We could not go for example, amoxicillin, this with the standard protocol, or EDC. This is so not like that. So there is no any standard protocol is available for this one, and lack of real time monitoring. So time consuming, cost effective, cost is too much. So real time monitoring is difficult. Another one, treatment and removal. As I said, so most of the Here we follow the conventional wastewater treatment, and it is, as I told, it is not possible to remove all the pollutant. Only partially it can remove. 50% will be example it can remove. So ineffective will be there. Another one, treatment cost is high. Next, sludge accumulation will takes place. So these and all challenges still in the emerging contaminants. Obviously, I said, so what are the effects we will get as a human being to the aquatic organisms? Next, environmental fate and transport. You can see the degradation pathway. So whatever I expect, it is a possible pathway only. So unknown degradation pathway will be there for different pollutant, and more toxic byproducts may be a chance to get it, and bioaccumulation is taking place. So next one is regulatory and policy gap. So I have showed you few countries are implementing this pollutants, right? Priority substance or emerging contaminants. So lack of global standards are available. So that is not there, and few countries only implementing this policies for the emerging contaminants. So these are the challenges is present in the emerging contaminants. Next one. So what is the current research? If you see 2024 or 25 papers and all, these are the area more research is currently happening here. So you can focus the scholars or MTech students, they can focus on this research, pharmaceutical and personal care products. You can see I showed you that pharmaceutical compounds, n number of groups are there to study still. So from there you can take pick anything. And another one, PFAS, that we will call it as forever chemicals, that is pre and poly fluoroalkyl substance. Another one, microplastics and nanoplastics, and then EDC. So that is endocrine disturbing. So these are the current researches going now. Okay. So what is the future scope available? So you can see here still I have shown only few, right? So apart from this, many emerging contaminants are still persist in the environment, especially you can see in the soil and sediment, and more research is taking place in the water or wastewater and all. So people they can focus on soil and sediment also, and we have to study the transport and what are the impacts of other mixed pollutant. I have shown few in literature view also. You can see that few pollutants only they tried. Still more pollutants are there to see that what will happen, how it will affect the environment, and what is the pathway will be there, and what is the toxic products will form or byproducts will form. So still more research is required on this area. And for the so degraded byproducts, I said. Another one, optimized condition. So for whatever we are doing in the lab scale level, we have to think for scale up process. Okay, so these are the future scope is available, and this is the overall presentation of this lecture series. Thank you one and all for listening my lecture patiently, and my kind request to everyone, please try to protect the environment by utilizing a natural way. And if you have any queries, you can ask me. Thank you.